All right, so today we are doing a deep dive on a piece of hardware with a, well, a name only a procurement officer could truly love.
That's a very kind way of putting it.
The NTI ST-C5VA-600. It's a VGA video and audio extender. And while the model number is pretty dry, the problem it solves is something I think anyone who's managed physical IT has battled with.
Absolutely. We're talking about getting a signal a really long way.
A really long way. How do you get a VGA signal from a computer to a monitor that's up to 600 feet away?
Yeah, that's like 2 football fields. And if you've ever tried to pull a thick VGA cable through a wall, you know the struggle. The connectors are huge, the cable doesn't bend, and the signal just dies after about 50 feet. It's a nightmare.
And so expensive. That's where this NTI unit comes in. It's basically a bridge, right? It lets you ditch that awful VGA cable for the long haul.
And you swap it out for standard Ethernet cabling, CT5, 5E, or CT6, the kind of wire that's probably already there.
So it's a system then, a local unit and a remote unit.
Exactly. The local unit hooks up to your source. Could be a PC, a Mac, Linux, whatever. And then the remote unit connects to the monitor way at the other end. It's a classic balloon setup.
Okay, and one thing on that local unit, the transmitter side, really caught my eye. This local access port.
Oh yeah, that's crucial.
It lets you plug a monitor in right there at the source, not just at the far end, which seems perfect for the main use case here, like a digital signage where the computer is locked away in a server room.
It's a huge quality of life feature for an admin. Think about it. If the screen in the lobby goes black, you don't want to run back and forth 600 feet to check if the PC crashed.
Right.
You can just check the local monitor in the server room. And you still get that crisp 1920 by 1440 resolution right there.
But that local clarity doesn't mean the remote image is perfect. That signal has to travel. And this is where the documentation, it kind of threw me for a loop.
I think I know what you're getting at. The cable types.
Exactly. In pretty much every other situation, we're told, upgrade to CAT6, better performance. But here, the source suggests that might actually backfire.
It's completely counterintuitive. It all comes down to a physical property called skew.
Skew. Okay, break that down for us.
So inside a CAT6 cable, the pairs of wires are twisted at very different rates. And there's often like a plastic spine down the middle to stop crosstalk for high-speed data.
Right, and that physical design is what makes it so good for gigabit data.
For data, yes. But for this kind of analog video, those different twist rates mean the physical length of each wire pair is actually different.
Ah, so the red, green, and blue color signals literally arrive at the receiver at different times.
Precisely. They get there out of sync.
Yeah.
And since this NTI extender doesn't have internal skew compensation, using that better CT6 cable just causes the colors to separate and smear on the screen.
So the superior data cable is actually the inferior video cable in this specific context.
In this specific context, absolutely. The older CAT5 or 5E standards have less of that variance, which means less skew. So if you want to hit that max distance without a blurry mess, you're actually better off with the older cable.
Let's talk about that max distance and the trade-offs. You said 600 feet. At that range, the specs say the resolution drops to 1/2 of 768.
It does.
To be honest, in a world of 4K and 1080p, that feels incredibly limited. Is that even usable today?
That's a totally valid criticism. You're not going to run a high-end marketing video on it. It would look blocky. But for, say, an industrial data display or flight times at an airport or a simple info kiosk, 124 by 768 is perfectly functional. It's about readability, not cinematic fidelity.
So you really have to know your application. High resolution means short distance.
Right. You get the full 1920 by 1440 at about 100 feet. If you need the full 600 feet, you sacrifice pixels. Simple as that.
And you have to tune it right. I saw that the video-only units have a manual adjustment.
Yeah, you're literally dialing in the quality based on the cable length.
Yeah.
The versions with audio handle that automatically, which is a nice touch.
The unit also seems pretty rugged. It can handle temps up to 100 degrees Fahrenheit and has built-in surge protection.
Which you definitely need if you're running copper between buildings or across a factory floor. Surges are a real risk. Plus, it's TAA compliant, which is a must for any kind of government contract work. It's just utilitarian hardware.
So wrapping up, we have a device that solves a very specific physical problem, getting legacy video from A to B, but it forces us to respect the physics of the wire itself.
That's the core takeaway, I think. We tend to see cables as just generic pipes for data, but at the physical layer, the actual construction of that wire, the twist, the shielding, dictates everything.
You can't just buy the most expensive cable on the shelf and assume it's the best for the job.
Not always.
Yeah.
And that leaves you with a final thought, doesn't it? how much of our slick digital world still depends entirely on getting these very old, very physical infrastructure details just right.
Something to think about before you rip out all that old CAT5. Thanks for listening to this deep dive. We'll catch you on the next one.